Okay, we've already talked about z-scores some, and we talked about in the last video about how normal curves could look very different from one another. So what we're going to do now is we're going to use z-scores to standardize any normal curve so that it becomes what we call a standard normal curve. Now the standard normal curve has a mean of 0 right here, it's the center, and a standard deviation of 1. All right, so we're going to take any normal curve that doesn't have a mean of 0 and a standard deviation of 1, and we're going to use a z-score to standardize it. And that way, once we've standardized things, we'll be able to look up the percentage or the probability of something happening. But for now, let's just deal with finding the z-score. All right, so we're going to look at an example similar to one that we have in our homework. I'm going to pull this up a little further. Fred averages 16 points per basketball game with a standard deviation of 4 points. Suppose his points per basketball game are normally distributed, so we know it's a normal curve. Let x equal the number of points per basketball game, and we run into some notation here. Then x is approximately normal, that's what that means, and our mean is 22, and our standard deviation is 4. And notice in those parentheses, the mean comes first, then the standard deviation. I'm sorry. This should be the mean is 16, and the standard deviation is 4. So somewhere when I copied this down, I copied something wrong. Because, of course, it tells us right there the average is 16, standard deviation is 4. All right, so we see that this is a normal distribution. It tells us that with these words, normally distributed. And the mean is not 0 and the standard deviation is not 1. So we're going to standardize it with a z-score. So suppose Fred scores 8 points in a game on Sunday. Then what is the z-score for Fred's points in this game? The 8 points is our x. The 16 is our mean, mu. And the 4 is our standard deviation, sigma. Let's fill in to the z-score. So we're going to have on top 8 minus 16 divided by 4. On top, 8 minus 16 gives us negative 8. On the bottom we have 4. And this gives us negative 2. Now that means that Fred's performance in this game is 2 standard deviations below the mean. And it's below it because it's a negative standard deviation below the mean. All right, we see that negative. If this had been a positive 2, he would be 2 standard deviations above his mean. Now, we can kind of see that, yes, he is below his mean. His mean is usually 16 points per game. He scored only 8 points per game. We would expect this to be a negative number. He's 2 standard deviations below his mean for this particular game.